Okay, so there's a lot to kind of unwrap in this question. I want to make sure we're on the same page throughout the whole thing. What I would recommend doing before you even jump into this first part of the first question is draw a picture for sine alpha and for sine beta. So for alpha, remember we're in quadrant 2, so it's going to look something like this, right? And your angle is going to go somewhere out here. Technically speaking, this is alpha, but we can work with its reference angle and be just fine, okay? So if sine alpha is 4 over 5, remember that's opposite over hypotenuse. So opposite would be here, hypotenuse would be here. And to find this other value, remember this would be our x value, x, y, and r. X squared plus y squared is r squared. So we're looking at x squared plus 4 squared is 25, or I should 5 squared for consistency. X squared is 25 minus 16, which is 9, and x is equal to 3. Okay, so we've got one of those triangles down. Now that we have this, this angle, we can actually find whatever other trig function that we want to find. Okay, we should also draw our second one, noting this one is in quadrant 1, so I'm going to draw it like this. There's our y and our x like last time. I'm going to draw it somewhere here in the middle. So this here is beta. Sine again, so let's draw this back side here. We have opposite and hypotenuse, right? So opposite is 1, hypotenuse is 2, and using that same formula, we've got x squared is 1 squared plus 2 squared. I did that totally backwards. We've got x squared plus 1 squared is equal to 2 squared. So x squared is equal to 4 minus 1. X squared is 3, which means x is equal to the square root of 3. Okay, and that goes down there. Now that we have this, again, we can find any of the trig values that we want to find. So the first one asks us just for a regular cosine of alpha. The reason for that is we're going to use it in the next couple of questions. So alpha is the purple one. So from here, we do adjacent over hypotenuse. Again, make sure you correct for the second quadrant. Cosine is negative in the second quadrant, so that's 3 over 5. Okay? Very similar for the second part of that question. It asks us for cosine of beta this time. And again, similar idea. We're in quadrant 1. We don't have to worry about a plus or minus change. But from here, we have adjacent over hypotenuse. So that's root 3 over 2. Okay, so now we're going to use this primarily for for questions 3 and 4. 3 asks us for cosine of alpha plus beta. We don't officially know either of these two angles. Could you find it? Sure. Do you need to? Not at all. So to find cosine, remember this is the sum, so we've got cosine, sine, sine, sine. All we have to do is plug in either the given values or the ones that we just found. So cosine of alpha, this is going to be negative 3/5. Cosine of beta is going to be root 3 over 2 minus sine of alpha was given, that's 4/5, and sine of beta was given, that's 1/2. So again, notice we're just swapping these out. I'm going to draw my arrows here. We're just swapping these out. When we write that 3/5 or that 4/5 or whatever, I completely drop the cosine and the angle as well. Neither of them stick around. So this just becomes a simplifying question. Negative 3 square root 3 over 10 minus 4 over 10, and we'll clean this up. One final statement of negative 3 root 3 minus 4/10. There we go. Okay, we have one more question kind of like this, and this one is asking us to find sine, and this one is the sum, so of alpha plus beta. Okay, and remember sine requires sine, cosine, cosine, sine. But just like the last question, we're relying basically on the values we already found. So sine of alpha, I don't know how well we can see it, was 4/5. So we've got 4/5. Cosine of beta we found was root 3/2. Plus cosine of alpha was a negative number, so plus negative 3/5, and sine beta was given as 1/2. So this is going to be 4 root 3/10, okay, minus 3/10, and let's write it out as a final answer of 4 square root 3 minus 3 all over 10. Okay? See you in the next question.